Now that the data file is in SPSS, we need to see if we need to reverse score any of the items in our measure or measures before we do anything else. Ideally, the notes we made when we were locating the measures for the measures section will have the information we need to know whether they're reverse scored items. Sometimes, though, I forget to include that information in my notes, and I have to backtrack it to the resources I used earlier. In the case of the short grit scale, you might remember I found the information on the internet that indicated some of the questions were scored differently than the others, but I didn't find information about scoring in the primary source for the short version of the scale. That led me to the article that reported on the process of developing the original version that was a little bit longer. When I searched that article, I found a note about which questions are reverse scored. That's circled at the bottom of the table in this slide. Now that I know that, I'll use SPSS to complete the process. You might remember I mentioned that there are some things you can do manually, changing each response at a time, but it's easier to do it in SPSS. This is one of those things. You might also wonder why I don't have you use find and replace in Excel. Good question. It's because SPSS lets us be more precise, and it generates a crumb trail to help us check our work. To complete the process in SPSS, we start by opening our data file, then selecting the Transform menu and select Recoding into the same variables. Note that we can also recode into different variables, which means that we don't replace the original data, but that makes our data set a little more complicated. It means each of the reverse scored items is in the data file twice, and I'm afraid I'd use the wrong one for analysis. When we select Recode into the same variables, it'll take us to a dialog box that looks like this. Remember, SPSS calls each of the columns in the data set a variable, but right now we only have the responses for the questions in the data set. Those are listed in the box on the left, and we use the arrow button at the center to move the ones we need to reverse score to the box on the right. Now we need to know which questions to reverse score. The authors of the short grit scale, one of whom is the same as the authors of the original grit scale, didn't make this easy by not including the reverse scoring information on their article. It's also a little complicated because the table from the article about the original scale didn't number the questions. I thought the numbering in the table for the short grit scale was based on the original scale, and I figured that out when I was labeling the questions in the data file and realized they skipped 3, 4, 7, and 8. I wanted to make sure though, so I took a screenshot of the two related tables and put them side by side. Literally then I drew a line from reverse scored question in the original scale to the question in the short scale. This slide illustrates that. If I weren't documenting it for this example, I might have also printed the two tables and used the table from the short grit scale to number the questions in the table from the original scale and crossed out the questions from the original scale that weren't in the short version. That said, now I know questions 1, 5, 6, and 2 from the short grit scale need to be reverse scored. You might have noticed that it works out that all of the questions on the consistency of interest subscale are reverse scored. We know that because the table is organized so the questions in each subscale are grouped together, the italicized questions are on the short scale, and all 4 of the italicized questions are reverse scored. So why don't we just score them the same as the questions for the other scale then? It's a good question. It helps us if we think about the name of the scale, the response options, and how we'd write and think about the score. Given the way the concept of grit is defined, the scale is called consistency of interest. Remember, the standard scoring would use the highest value if the participants responded very much like me. The way these questions are worded, though, saying very much like me would be more like a lack of consistency of interest. It's a little tricky to articulate what the score would mean from there, so you can imagine how tricky it'd be to write about and understand. And it's actually a lot easier to reverse the scores. That might lead to the question of why don't we just code them this way to begin with? Why change them and then change them again? Another good question. That's exactly how the instructions are worded when it's used for personal reflection, and each person computes their own score. When we have responses from multiple people, though, and we're coding or typing in the data, it can get really confusing to switch back and forth between different values. And that creates the chance of errors in the data, which creates threats to reliability and validity. It's actually easier to use the same values for each response for all of the questions, then complete the reverse scoring process in another step. Now that we know which questions we need to reverse score, the process in SPSS is relatively simple. We'll select the variables or the questions that need to be reversed from the list on the left in the dialog box, and click on the arrow in the middle to move them to the box labeled Variables. The top screenshot in this slide shows what the dialog box will look like when you select a question, and the second one shows what it looks like after you move the question to the Variables list. The bottom screenshot shows what the dialog box looks like when we have all of the questions that need to be reverse scored in the Variables list. In other words, as long as the questions are coded the same and reversed the same way, you can do more than one question at a time. To move on from here, we'll click the button labeled Old and New Values that I circled at the bottom of the screen. That will take us to the dialog box where we tell the software what to change. For our purpose, there are three important areas: the box where we specify the old value, the box where we specify the new value, and the box where it keeps track of the resulting pairs. The response that the participant selected is called the old value, and the score we want to change it to is called the new value. The idea in this process is that we literally flip the scores. If 5 was the highest and 1 was the lowest, we would change 5s to 1s and 1s to 5s. We have to tell SPSS what to do with each response that needs to be changed. To do that, we put the original response in the text box under where it says old value, and put the reverse of that response in the text box under label new value. So this example is changing 1 to 5. After we enter the values in those text boxes, we need to press the button labeled Add, where I have the star in this slide. After we click Add, SPSS will add the pair in the box labeled Old to New. Then we do the same thing again for the next set of numbers, and again, until we tell SPSS all of the changes that need to be made. Each time we click Add, SPSS will add the pair to the box labeled Old to New, so you have a running list of the changes it'll make, which is really helpful to keep track of where we're at. You might notice I included the middle number, even though I entered 3 changes to 3. When the response scale has an odd number of options, the middle number will stay the same, but I usually add it to the list to make it a little easier to keep track of the flow. After all of the pairs are entered, we click Continue. That takes us back to the original dialog box where we click OK. This is the one place that having the output window is really nice. It records the details of the change to remind us what we did, confirm it was done, and help us check our work. The change in the data set is almost invisible since we're recoding it into the same variables. Now that we have all the data in the file encoded accurately, we're ready to compute the score or scores from each participant.